Okay, so next up we have Heidi. So Heidi is a consultant at the Information Lab in Germany, and she's going to talk to us today about be rational, why pie charts are not your answer. Are you there, Heidi?
Yes, I'm here. All right. First of all, thanks to Emily and Alex for organizing TFF time and again, and to Sarah, Simon, and Lorna for hosting this year, and also to CloudStream Partners for sponsoring. If any of you should have any questions during my session, feel free to ask them using the Q&A function, and I will try and get to them at the end of my session. If I should not have time for that, feel free to reach out via Twitter, LinkedIn, Instagram, if you like, and I will show you my contact details again at the end of my session. All right, so pies. What is it about pies that makes us abandon all rationale? Well, first of all, pi is an irrational number, so that might have something to do with it, or not. Either way, pies may be delicious and a not so secret passion for many, or not such a small number of dessert enthusiasts. But does that mean we have to use them as a chart type? Pi, the mathematical number, has an infinite number of ever-changing decimal places. It is said that at some point, the decimal places of pi, when converted to ASCII characters, will tell you your whole life story, the secrets of Area 51, and even the ending of Game of Thrones. But does that make pi the answer to life, the universe, and everything? No, because that's 42. And 42, other than pi, isn't irrational at all. So why would you be? Why would you seek to answer a question with something as irrational as pi, or pie charts for that matter? Maybe we should talk about that. Maybe we should have a talk about what it means to be rational, why pie and pie charts are not your answer. When teaching how to create pie charts in my Tableau Fundamentals workshop, I always tell my participants that pies aren't exactly best practice, and I receive varying levels of outrage at that statement. Users say, but people want to see them, but they're so easy to read, but I love them. And yes, it is true that pie charts do have certain strengths. They display a part-to-whole relationship in a very obvious way, but they also have weaknesses. The magnitude of individual slices is not easy to judge unless it's close to 25, 50, or 75%. And even then, those are only easy to read when starting at 0, 90, 180, or 270%. So pies don't actually show anything that can't easily be shown in a bar chart as well. Let's take a look at an example. So here we can see a pie with 6 slices. And let's take, for example, company C. It's about 25%, and that is easy to see. But at the moment, the slices are sorted alphabetically, which is not exactly best practice. You would usually probably sort them descendingly by magnitude. And then you have something like this, and it's not as easy to see how large the slices are. We can, of course, label them, but then we still have to compare with the color legend which slice belongs to which company. So we can also label the company then, but then the pie chart is almost completely redundant, because of course it does give us an indication of how large the slices are, but to get any real information out of this, we are going to read the labels, and we have to read them clockwise in a circular way. So it would be much easier to just use a table instead. It contains the same amount of information and is much easier to read. Or we could use a bar chart, which is much easier to see because the human eye is better at perceiving length than angles or areas. And the labels are easy to read, so we can easily see which bar belongs to which company. And the axis does show a percentage, so it's easy to think of this as a part of whole relationship between the bars. William S. Cleveland said, when a graph is made, quantitative and categorical information is encoded by a display method. Then the information is visually decoded. This visual perception is a vital link. No matter how clever the choice of the information, and no matter how technologically impressive the encoding, a visualization fails if the decoding fails. Some display methods lead to efficient, accurate decoding, and others lead to inefficient, inaccurate decoding. So we are going to talk about this kind of inefficient or even inaccurate decoding. There's many types of pie charts or many ways of using pie charts. So pie chart does not equal pie chart. And there's many lovers of pie charts out there who will not use any other chart type. While I do not exactly understand that, I do respect that. And I would like to help at least avoid the worst mistakes you can make. So let's talk about worst practice. Something like this pie was one of my first projects I did for the information lab. Now you can see that it's far too colorful and has far too many slices, but that's not the bad thing about it. So let's look at what we're seeing. The legend gives us a number of providers, and we can see that in the legend they are sorted alphabetically. But the biggest share, the dark blue one, is at the very end of the pie chart, even though it is at the very beginning of the legend. So let's label this. And we can see that there are negative figures in here. I was working on this project with my dear colleague Helmut, and I will never forget what he said when we saw this. He said, if you take a slice out of this pie, it gets bigger. Now, while this may be a dream pie, something that gets bigger even though you eat it, that's all it is, a dream. It does not depict reality, and it completely distorts the picture. This is not a part to whole use case where you should use a pie chart. So what we did was we created a bar chart instead, and the client was pretty happy with that. So bottom line, do not ever use negative figures in a pie chart. Another example. This pie looks at what types of cancer women are most likely to develop. And it looks as though about 35% of all women are going to develop breast cancer at some point in their life. But is that really what this pie says? Let's take a look at the labels. And no, this actually says that 1 in 8 women will develop breast cancer. And while that is still a lot, it's not 36%. So I have seen this one called a Gestalt pie chart, because the whole is greater than the sum of its parts, meaning all the slices in this pie do not add up to 100%. The issue here is that we do not have a parts to whole relationship in this pie. Each slice is part of all women, but there is no relationship between the slices. So what we should do instead is use, for example, a bar chart to show the likelihood of developing a certain type of cancer. And if you like, we could even use another bar chart to show the likelihood not in percent, but in the number of women out of which 1 might develop this type of cancer. Now, a third example. You all might know this young lady. And if you don't, then maybe you know this chart. This diagram of the causes of mortality was created by Florence Nightingale. It is one of the most famous historical charts, not because it was the first chart to visualize numbers, because it wasn't, but because it was the first that was used to make a point and to press for change. Many see this as a pie chart, but it's actually not. That's why I call it the Florence Nightingale faux pie. it's actually a circular timeline. So reading around the clock, starting at 9 o'clock, we see a temporal development, and we have 1 year in the right-hand side pie and another year in the left-hand side one. But for a timeline, line charts are actually better. It shows the development far better, and we do not have the gap between the 2 years as we had with the 2 Nightingale faux pies. And it is far easier to see a trend. So these were the 3 worst practices you can do. So let's delve into better practice. Oh wait, better practice. Number 1, comparing 2 pies. Take a look at these 2 pies. They show how students feel about science. The students were surveyed before and after their first science class. The first thing you might notice is that the colors are not very intuitive. You will see that bored and excited have pretty similar colors, even though they depict sentiments from the exact opposites of the spectrum available. What we can also see is that after their first science class, many more students got excited and many didn't feel just okay anymore. So bored and not great do look kind of the same, and it's very difficult to gauge if kind of interested changed at all because it moved its position within the pie. So let's show the numbers. We can now see that bored and not great did actually grow, even if only slightly, and so did kind of interested. But the development is very difficult to see, even when the numbers are showing. So what might be a better chart type? We could use a stacked bar chart. Now it's easier to see the amount of very positive and very negative replies. So we can see excited and bored, but it's not easy to compare the slices in the middle. So when we color it more intuitively, it's easy to compare the amount of rather positive and rather negative replies. So summing up excited and kind of interested, or not great and bored, but still not super easy. So what we could do instead is use a slope chart. This shows best the development of individual replies. And we can see that overall students are better informed after their first science class. So fewer people are only okay. Those probably just didn't know what to think about science before. And many got more excited about science, but also some, now knowing more about science, could reconfirm that they're just not that into it. Now, this is comparing 2 pies, but what do we do when we want to compare multiple pies? What do you do when you have a question where you want to show the parts of multiple wholes? For example, who survived the Titanic disaster? Who survived and who died in the disaster of the Titanic's maiden voyage? That is easy to answer in one chart only. But maybe the answer is more multifaceted than that. Maybe you want to check if wealth could buy you a seat on a lifeboat, or maybe you want to know if it's true that it's women and children first. So we want to break up the passengers by gender and class. And for that, we need to use multiple pie charts. What you can see now is that men in general were less likely to survive than women. But does this paint the whole picture? What about the number of people per gender and class? So let's put the number of passengers on size, and then we see a completely different picture. So we see that, for example, most female crew members may have survived, but there were very few female crew members to start with. And on the other hand, the largest group by far was male crew, of whom more than 3/4 didn't make the journey. Multiple pies, especially with different sizes, are not easy to compare. So maybe we could use stacked bars instead. But then again, we do not have the size element of absolute numbers. So what if we could have the easy readability of a stacked bar chart with an additional measure on size? This would be called a Marimekko chart. And if you listen to my talk, Run Before You Walk at TFF North America, this is the one I was talking about. Now, this may not be the easiest chart to start users on, and it takes a while to read into, but it beautifully shows a two-way part-to-whole relationship. Vertically, on the y-axis, we can see the percentage of people who died within a group. Horizontally, on the x-axis, we can see the percentage of that group out of all the passengers that were aboard the Titanic. So while this is no standard chart type, it does retain the simplicity of a bar chart. Third example, comparing slices with huge size differences. Imagine you want to compare different departments of a company, for example. You can use any KPI, number of employees, number of sick days, required data storage capacity, anything really. Some departments are your usual, let's call them supporting departments that keep the company running, like IT, controlling, sales, you name it. But one or two departments are crucial to your industry and product, so they are far, far bigger than the other departments. A pie chart might look like this. One department taking up more than half the pie, and some other departments landing below the 1% mark. Now, it is not ideal to show this in a pie chart, so maybe we could use a tree map instead. Instead of pie slices, a tree map shows rectangles of varying size. It's pretty simple here to gauge a hierarchy between the different items, or in this case, different departments. You can see at a glance by how much your top N items are the biggest, and it gives you an idea about the weight your top departments carry. In this case, however, we have data for several months. So we could show that in a line chart, but it would not show the changes in the smaller departments very well, because the biggest department stretches the axis way too much. So instead, we are going to use a bump chart. The bump chart shows the rank per department for each month. And it is easy to see where smaller departments switch rank with each other over time. The absolute numbers in this case are of a lesser relevance, but we could add them in the tooltip for additional information, absolute numbers and the percentage. Now, I showed you my top 3 worst practice examples, 3 examples for better practice, and I want to give you a few hints for best practice. First of all, evaluate. I would love to say, don't use pie charts ever again, but I won't, because there's many cases in which there is a reason to use pie charts. For example, your boss wants a pie chart in an ad hoc report and it's just not worth fighting over, or your users insist that they won't look at your report if it doesn't contain a pie chart, or you want to ease your consumers into a new report and give them something familiar. But please, first stop to evaluate if your use case is one that can be answered using a pie chart. Does it show development? Then please use a line or bump chart. Do the slices not exclude each other and thus don't add up to 100%? Then use a bar chart. Does it compare 2 different points in time? Use a slope chart or stacked bars. Does it contain negative numbers? Use a diverging bar chart. Does it contain several groups of a whole of different size? Use a Marimekko chart. Second, minimize. When everything is important, nothing truly is. Do not drown your consumers in visual impulses. Use colors sparingly and group slices where possible. Usually only one slice is truly important. For example, it's your company against the competition. So highlight the important slice using color and show the others in grayscale. Third of all, maximize. This may appear a little counterintuitive, given that I just told you to reduce impulses, but this is actually a part of minimizing. I told you at the beginning that the eye doesn't gauge angles very well and that it's better at comparing lengths. So maximize the use of the real estate on the dashboard giving to you. The center of a pie is really only color without information. So optimize your ink to data ratio and make your pie a donut. A huge benefit of the donut is that the eye is tricked into thinking that it's looking at a curved stacked bar, and it's better able to compare the different slices. Now, this is not ideal, but it's better. Now, you may be wondering, how does this maximize your use of real estate when you now show even less than before? Well, you can show the total in the center, thus giving more information. Or you can put the question into the center which your donut is answering, thus saving space of the title. If you're now thinking pies, donuts, are there any more dessert charts? Well, yes, of course. I will not go into waffles at this point, but there are lollipop charts. Lollipop charts are the perfect choice if you want to show a more creative bar chart. The strength of lollipop charts is that they emphasize the end of a bar. This can be especially helpful with smaller bars that would otherwise go unnoticed, like Company F in here. Fourth, obviate. Now, I just implored you to optimize your data to ink ratio like a minute ago, and now I'm telling you to show the same information twice. Your consumers may insist on a pie chart now, and their data literacy level may be so low that pies are a valid option. But please, teach them data literacy, and teach them by putting the same information in a more informative chart and putting that one next to the pie or donut chart. Slowly loosen your users' death grip on the pie chart and get them used to bar charts, line charts, slope and bump charts, and even Merrimack charts in time. Make the pie chart redundant until such a point when you can get rid of it. Fifth of all, be rational. There is no silver bullet for every question, and I cannot give you the answer for all your dashboard design questions. I can simply implore you to be rational and think about why pie charts might not be your answer. Thank you.
Thanks, Heidi. Next up, we have Kendra, who is going to be starting at 3:10. So we've got about 6 minutes. So yeah, we'll just take a short little break and we will get back here at 3:10.